Well, hello everyone. Welcome to today's webinar on non-contact conveyor solutions for volume flow measurement and condition monitoring, focusing on 6 bulk scan LMS 511 LiDAR sensor. So I would like to encourage each of you to use the Q&A chat box at the bottom right corner or somewhere on your screen there in case you have any questions. And we love having the questions. They're really good for us to hear the feedback and the questions. So we'll collect all those questions and make sure to answer them during the Q&A session that we'll do at the end of the presentation. So welcome again. Thank you. This, make it more interesting here in the morning. We should make this a drinking game, but with tea or coffee or whatever you have. So maybe every time I say conveyor, you can take a sip. Maybe by the end, all the caffeine will start building up. So make it interesting here. I'd love to be talking to you guys each in person, but I appreciate you coming on virtually and picking up this information. So this webinar is within a complete series of webinars about 6 solutions for process automation and gas analysis for the cement industry. So if you want to receive more information about our previous sessions on any of these topics, emission monitoring, collision avoidance in cement factories, please let us know. Reach out to your SICK contacts that invited you here, and we can give you the recordings of those webinars. So today's session will also be recorded. It's being recorded right now. We'll also send you the video link as well as the presentation stuff in an email within the next couple days. So coming to today's agenda, and there we go. We're going to talk a little bit about who SICK is. There'll be a short section about conveyor operations and industrial applications, things you probably already know, but just, what are the conveyors we're talking about here, where you find them, what they're used for. Next, I'll present some of our sensor applications used on conveyors to increase the level of automation, reducing downtime, increasing production efficiency. And then again, we'll focus on the volume flow monitoring and the different features of the bulk scan. Finally, we'll have a short summary and then the Q&A session. So please, again, make use of the chat function or the Q&A function there and with any questions that you have today, and we'll compile them as we go. All right, and the next slide. So who is SICK? So, I'm here in the U.S. I'm in Minnesota, and we are one of the largest subsidiaries of SICK, which is a German-based company. They have more than 70 years that we've been doing manufacturing sensors and sensor solutions for industrial applications. The company is active in fields of factory, logistics, and process automation. We have more than 10,000 employees worldwide, and we have a global sales of more than 40,000 different products, which are either used to increase work safety or to automate and optimize production processes or to provide information for environmental protection. All right, so getting here to this particular one of these 40,000 solutions that we have, what are the tasks of conveyors? So we're going to be talking about conveyors and moving material in cement factories. So at cement factories and manufacturing and cement handling, we move heavy and bulky materials like fuels, coal, bio waste need to be transported. Sometimes this could be over several miles. For example, if the limestone quarry is located in a different area than the actual production plant, or let's say when a clinker or cement needs to be transported from the plant to a harbor or ship terminal. Conveyors are also one of the most important machines to maintain a nonstop flow of material and fuels inside a production plant. As we're often talking about a continuous process, which runs 24 hours a day for more than, at least 300 days per year, a constant supply of these consumables has to be guaranteed at all times. The conveyors are also responsible for the correct accumulation, sorting, and dosing of each component. That's very important in order to maintain the desired product quality and quantity. On the picture at the bottom left, you can see conveyors are also used not only for those large distance runs, but also to overcome obstacles and heights. So conveyors are an easy way to elevate bulky materials more efficiently than using mobile vehicles. The process we're discussing today are typically used in cement plants, but they can also be found in lime production plants, as well as in the power industry, waste and recycling, metals and mining, chemicals, and then ports and harbors, and a lot more. As I mentioned, all kinds of conveyors are in place at the cement plant to transport different raw materials, fuels, and products with different size and shapes from one point of the plant to the other. So there are many different conveyor applications and conveyor types used in cement production. For example, there are belt conveyors, which are used for longer distances. They're vibrating conveyors for sorting and transporting. Bucket conveyors to elevate the bulk material. Pneumatic conveyors, where like the fine powder is fluidized by compressed air and moved along. And roller conveyors, usually used to transport the cement for shipping if the final product is bagged and palletized. So with all those conveyors and everything moving around, how do you determine how much material is being transported on these conveyor belts? Typically, mass flow on such a conveyor belt is determined by the use of belt scales. These belt scales are mechanical devices which either replace a short section of the belt or mounted below the belt in between the belt support structures. These devices measure the mass flow by weighing the amount of material on the moving belt. However, from our experience, I can say that there are a lot of cement producers out there facing huge problems with underperforming belt scales and inaccurate readings, which cost users a lot of money every time the belt is in operation. For example, the reading can be affected by the moisture content of the transported material, especially if you're operating outdoors. When the material is wet, the total mass flow increases and the measurement result will be incorrect. The plant operators often have the problem of not being able to position the belt scale where they would like it to be, since belt scales can usually only be installed within not installed near an inclined angle or before or directly after curves, as these are often leading sources of vibrations and reduced accuracy. Also, as belt scales are mechanical moving parts and in contact, jamming can happen quite easily. In order to keep the systems running, plant operators often spend many hours calibrating these devices. And to calibrate it, the belt needs to be stopped, and the different weights are placed on the scale to correct for the measurement error. This means additional downtime whenever the belt is calibrated. Also, it can happen that when the belt tension is too high, you bridge over the scale. That could be an issue. And if the tension is too low, the material might shift on the belt. Both of those can cause repeatability errors as well as material spillage. So the maintenance, of course, is a huge cost factor when operating belt scales. Just think about the calibration effort and the time it takes to cut the belt, put it back together when the scale is broken. And if the belt is not loaded or evenly vibrating, this will affect the reading as well. Various other points like belt design have an impact on the measurement, in particular accuracy and repeatability. So we have a little poll question coming up here. You guys can kind of give me some input on what you guys do use for your measuring. So one of the things we're going to talk about next, why I brought all that up, I mean, if you're a cement manufacturer and producer, you know all these things. So those were all brought up to here's how we understand what's going on in the facilities and for moving product. So after having listened to conveyor belt operators, your needs, and because SICK is very experienced with optical measurement principles, many years ago, SICK came up with a completely new approach to measurement, the infrared non-contact volume flow measurement device, the bulk scan, LMS 511. That's basically a class 1 LiDAR sensor, so it's a laser ranging sensor. This device sends out a high pulse laser beams and is able to create a profile of the material on the conveyor in real time. Using this method, the scanned height profile across the conveyor is multiplied by the belt speed and represents volume flow. The bulk scan has an internal density or mass flow calculator so that it can also calculate the mass flow. The device is universally usable since it can be mounted only 20 inches from the conveyor, so it can be really close, or up to 65 feet above the conveyor belt without any physical contact with the material or the conveyor. It has a scanning angle of over 190 degrees, and it uses this 5-echo technology, which I'll talk about more later, and that helps to have a highly flexible and robust device, which can be installed on pretty much every open conveyor. All right, so I'm going to move that out of my way. There we go. Move the poll. So how does this measurement methodology work? So the bulk scan scans the surface contour of the measured object using a rotating laser pulse. So there's a laser in there, it's rotating around. And it shoots out the lasers, and it calculates the distance of each point measured, and therefore defines that surface contour. So during commissioning, the bulk scan initially learns the reference contour, which is an empty conveyor belt. It's like hitting tear on a weigh scale. That's your empty condition. The bulk scan initially learns this reference contour, which is the empty conveyor belt, and uses this information to calculate the difference between an empty and a loaded conveyor belt. This information, when combined with the belt speed, which can be determined by an encoder directly connected to the bulk scan, or you can send it a fixed value and say, here's my belt speed. And that gives the volume flow. And then you take the volume flow, multiply by material density, if you know what that is, or you can calculate it, results in a mass flow. So this method not only gives us information about the amount of material being transported, but it also gives us a control value to adjust the conveyor loading upstream, as well as conveyor speed, which can be used to adjust and to achieve exactly the right volume of material to be delivered. In addition, the optical measurement principle can be used for overfill protection of conveyors, feed chutes, and transfer points, since the bulk scan is mounted on top of the equipment. So it can look down and see about height and overflow. This mounting position also has a benefit of reducing maintenance costs and downtime, since the bulk scan is not in physical contact with the material transported or the conveyor itself. The bulk scan does not require any regular calibration. In addition to the bulk measurement values, we get some more stuff. Roller and belt movement can be tracked. We'll see that in a little bit later on how that's done. In general, we can say that by using this kind of technology, overall production efficiency is increased since downtime is reduced. Output is increased and energy as well as workforce is minimized. Now let's look at some basic technical information about the device itself. The bulk scan uses an eye-safe infrared light source, which means that the light emitted in normal operation is not harmful to eyes or human skin. And I'm contrasting that to some other technology, like there's no nuclear radiation used here, and no special precautions or seminars or anything need to be taken for handling any type of radioactive material, which some similar systems use. So this class 1 laser doesn't require any additional health or safety concerns. The IP rating and temperature limitations are already great, but they can be extended even further if needed by putting the device into an enclosure with a glass window, which protects the device from even more harsh environments. So with the scanning angle of more than 190 degrees across the conveyor, and that can be limited because we don't need 190 degrees, the device is able to see and scan everything within this orange area here. And the device can be mounted just 20 inches above or 65 feet above the conveyor belt. That capability gives us great freedom when it comes to finding different mounting locations. In fact, the bulk scan does not even need to be mounted directly above the conveyor due to this high variability in range and scanning angle. So you want to compare this with the limitations of traditional weigh scales or nuclear devices, and you can see the flexibility and advantage of an optical device, being able to mount it anywhere you want it to be. So, but aren't optical devices difficult to use in outdoor and dusty environments? I mean, particularly the extreme conditions of a cement plant. So in order to make the system reliable for these harsh outdoor environments and to limit the influence of different ambient conditions, the bulk scan is equipped with something that we call the 5 echo pulse technology. This means that the sensor is sending out 5 different laser pulses with different intensities and configurations that the sensor is able to distinguish these different echoes received from possible disturbances. This gives the bulk scan highly reliable measurements, even under harsh weather conditions or internal conditions, even if it's inside. The dust, the cement dust, of course, is quite intense. Rain, fog, other conditions. Another advantage of the 5 echo pulse technology is allowing for the sensor to be mounted in an additional enclosure with a glass window to protect the device further. The sensor is smart enough to be able to pick up all those different echoes and returns and actually get through and see that the final return from the material on the conveyor. So using infrared laser technology gives us a possibility to determine the volume or mass flow on the conveyor belt, like we've been talking about, but the laser beams also tell you the exact height of material on the conveyor. By doing so, large rocks and other things, especially if you're running alternative fuels, can be detected in a timely manner, and downstream equipment can be protected by stopping the belt before any damage occurs. Also, the probability of overfilling is minimized by using this height information. Bulk scan also detects an uneven loading of the material on the belt by calculating the center of gravity of the load. The bulk scan also monitors the edge of the conveyors and how close the material is to the edge. Doing so, expensive conveyor belt is reduced, belt life is increased, and maintenance is minimized. All of this is achieved by using just one maintenance-free, non-contact measurement device on top of the conveyor. So we know the amount of material going by, we know where the material is on the conveyor, we know how much material is on the conveyor, how tall the material is, and we even track the edges of the belt so we can see if we're starting to see some slippage or rolling up or down the rollers. The bulk scan has several digital inputs and outputs. So once it gets all that information, how does it talk to anything? So we have an Ethernet interface to distribute and exchange the information. We have an analog module that you can take inputs and outputs, convert to analog. We also have different function blocks to be able to make the integration to common PLCs like Rockwell, Allen Bradley, Siemens, and Beckhoff PLCs as well. So due to this unique measurement principle, bulk scan can be used in many different applications, not only for belt conveyors, but also to check and monitor the fill level of crushers, for example. There's a possibility to measure the volume flow of all open conveyor types and to optimize their operation, no matter which kind of bulk material is being transported, whether it's raw material, cement, coal, or alternative fuels. In addition, bulk scan can be used on bucket, pan-shaped, apron, or drag chain conveyors. The same measurement principle is, by the way, also used on our 3D stockpile measurements out in your yard, as well as train and truck profiling and filling applications, where operators can use these systems to optimize their storage and logistics processes. You know, pictures say more than 1,000 words. So, you know, it was 1,000 words, but now with inflation, you know, probably 10,000 words. So let me show you some of our installations and aggregate sites all around the world. Here we can see a bulk scan installed on top of a clinker cooler in the cement plant. Let's flip through some other just pictures here. Here, you know, we're using devices to be able to warn the operator when the belt is overfilled and if the belt speed needs to be adjusted. Here we have, we did a public thing with this company, some public marketing. There's different installations. So we're above conveyors of all different types, looking at all different types of materials. So, you know, to sum things up, there's definitely no doubt that more and more cement companies are making use of sensors and smart sensors to digitize their value chain, especially in the transportation and logistics processes. However, an integrated data process is needed to get all of that information in. So we can help create better productivity, increase resource efficiency, reduce equipment downtime, and increasing plant safety. Making sure stuff isn't falling off of conveyors and making sure that things are operating the way they should, and being able to monitor what's on the conveyor is a very important part of that. Furthermore, these sensors can be used to give a reduction in CO2 emissions. If you know how much material or fuel is going in and your output on the conveyor, if you know what those numbers are, you can make those changes. And the sensors make your production more flexible and easily adaptable to new situations. The data can help you to reduce production and maintenance costs, while at the same time increasing customer satisfaction due to increasing your product quality and on-time delivery. Sensors are used to protect people and machinery, and the data is often used to create new business models and payment methods. For example, maybe a real-time pay-by-volume agreement between a quarry operator and a cement plant. So having said all this, I believe SICK is the right partner for you to achieve your automation goals, whether it be this or any other automation sensors and solutions that you're looking for to create added value for you and your customers. So if you want to know more about bulk scan and its applications, you're welcome to check out our many articles and information that have been published in journals such as the International Cement Review and talks given here at our IEEE Cement conferences. We also have an industry guide. You can get more information about SICK's efficient solutions for process automation and emission monitoring in general. And our SICK website, as well as SICK YouTube channel, has some very good content. So with that being said, with those words, we've come to our Q&A session. So let's check in and see what questions have already been asked.
Yeah, thank you, Dan. We've got about 10 minutes remaining. So for anybody who does have a question, please place that in the Q&A section. Otherwise, the question I have here, Dan, is how small of a material can be detected and measured?
Okay, so Yeah, we had like big lumps of things and rocks and clinkers and things like that. The some vibration on the belt, and the precision of the laser, we're looking at something maybe 20 millimeters. So if it's less than 20 millimeters, so if it's kind of a fine powder on a conveyor and it's less than, let's say, 10 millimeters, we may not see it. 20 millimeters is probably a pretty good level of an amount. Anything less than that will probably say, hey, the belt's empty, which is a really good other application, is just when you've got miles of conveyor all over the facility, this can easily tell you, hey, your conveyor's empty. And you can stop it, or maybe it's not supposed to be empty and you have something plugged up. So about 20 millimeters, I would say, of material on it. Any other questions?
Great. We have had one more come in. What is the initial cost compared to traditional belt scale?
Okay.
Just if we can sum that up somehow.
Yeah. It's typically a lot less. Now you gotta look at all of it, the total cost of ownership, right? So the hardware is about the same, depending on what kind of belt scale you get and where you install it, and are you including installation costs? The installation for a scanner like this is very simple. I mean, it takes a little bit of time because you got to get up on a fork truck, or a lift and mount it, but that's really it. And then you just, through a free program and a laptop, you set your angle. Hey, there's my conveyor. You can visually see it on the screen and go, there's my conveyor. I'll set my range. You just use a mouse and drag it around, and you hit a button that says learn, teach, and you teach that empty conveyor, and that's kind of it. There are some things that can be adjusted for if you have highly reflective materials. Maybe they're wet. Maybe there's different vibrations. Maybe you have different compression. So things you can tweak, certainly, but the setup, the equipment is fairly low cost compared to other equipment. Certainly compared to nuclear measurements, there's the ongoing maintenance and calibration and setup is so much less with a non-contact solution over the conveyor like this.
All right, great. We do have one last question that's come in. You mentioned better accuracy with wet materials. Is it possible to input moisture or water content to get corrected values?
Yeah. And you can input what the density is. So if you know that it's wet, or if you did something else to measure the density, you can actually input and have that density change live as many times as you want to either send an updated analog signal or an Ethernet command. Just send it, hey, here's the new density numbers. Density is an interesting challenge and very important to have for lots of reasons. For if you want to dry the materials, or just knowing how wet it is, and changes between volume and mass. When you're using a weigh scale and you're trying to calculate volume, you're using this density number. Is it correct or not? When we're measuring volume, which is what the bulk scan does, and we're trying to get mass, we're using that density number. So that density number is critical. Now, if all you want to know is the volume, because you just want to know how much of something, the bulk volume, well, cool. Well, then we're good. What we can do, as much as I talked about how much better this is than weigh scales still do what they're supposed to do. It's just you have recalibration and the effects of installing it. So what some people are doing is you leave the weigh scale in one location and you put the bulk scan over the top. And that gives us something very unique here. Now we're getting mass. Now, for all the reasons, is the mass accurate? Is it repeatable? Is it bridging because of the belt tension? All that stuff I mentioned. But you are getting some value of mass. And at least if it's repeatable, it may not be accurate, but if it's repeatable over that period of time, you can say, hey, this new stuff we just dumped on here is weighing more. Is it accurate or what? I don't know, but it's weighing more. So now you have mass. And from the bulk scan, you have volume, bulk volume. You can actually now calculate density. That's been nearly impossible, if not possible, to do in a real-time, live, in-situation density measurement. And now you can use that information to say, hey, this stuff that we're running now, it's the same volume, but it's lighter. Or, okay, it's less dense, maybe it's dry. Or it also gives an information on the size of the rocks or the different things. If they're really big chunks, there's more air gaps in there, so it's less dense overall. Again, it's also, I've been using the word bulk density because it's or bulk volume, I should say. Bulk volume. It's the volume of the bulk, as if you were going to load it into a trailer or load it into something. It's how much room it takes up. This isn't the same as taking those chunks and putting them into water displacement and seeing what the real volume is of it. It's bulk volume. So as far as that density, yes, if you're running wet materials, you can tell it, hey, I have a higher density now. What's my mass? But I would offer a thought of kind of always thinking, instead of always thinking about mass, because that's all we had were these weigh scales, start thinking, do I need mass, or is really volume an interesting thing for me to know? And then you can possibly translate that into mass later if you need. That was a long way.
Great, thanks, Dan. We've had 2 more questions come in. I think we probably have time for. The first is regarding connectivity. So it's, does this have Bluetooth?
It does not have Bluetooth. It's so good it has blue teeth. It does not, and that would be interesting. So please contact us with what your interest is there. What we find with the Bluetooth, I don't know if you just meant for just initial setup. That would be nice, like when you're right next to it. And SICK is starting to put out a lot of sensors, but more kind of indoor factory automation sensors with Bluetooth. And there's industrial Bluetooth. But what we find is, as far as transmitting the data, the environments that these are in the metal and the motors and things aren't typically always shielded, because we're not trying to run sensitive electronics typically in these environments. Bluetooth isn't going to hack it. We don't even often try to do Wi-Fi in these situations, but I could see for a fast setup. That all being said, we actually have a radar an 80 gigahertz radar level sensor that's also used in these environments. And that setup can be done over Bluetooth. You know, you gotta be real close to it and set up to it. But the bulk scan at the moment does not. But let us know if that's needed. There's always modules. We have some really cool wireless data collecting and even cloud and remote connectivity options that might fit what you're looking for.
They actually responded here, Dan, saying Bluetooth for changes to adjustments such as density is kind of what they were referring to.
Yep. And if you're real close to it, you could do that. We could set that up with a module, or you get one of our kind of communication modules with different gateways. But most people, unless you're standing right next to it, Bluetooth isn't probably going to work. So we just send information just over Ethernet. So from maybe a main area is like, hey, this new stuff is being dumped on. We think it's wetter or drier, whatever it is, and then you can send that command over Ethernet.
Great.
Yeah, go ahead.
Oh, I'm sorry, Dan. I was going to say, for the sake of time, we do have one last question, and I think that you would have time to get through. That is, can bulk scan sensor be taught to ignore a part of the belt that may have a rip or some other imperfection?
Yes, in a way. Not there isn't a way to say, hey, if there's an imperfection, ignore it. But if there's if there's like lumps, or there's any kind of conveyor that has ridges, or like a bucket conveyor, what we do is we teach that, and then we know if there's gaps, we ignore the gaps, and we can basically try to ignore different things on the conveyor. Now, rips and things that pop up that we don't know where they are, or they're not repeatable, it's going to look, if the belt is curled up, it's going to look like bulk volume, and we're going to add that. That being said, we actually have other solutions within SICK to look for exactly those things. We have some cameras that are looking for that. We also have very specific sensors that can be used to check the staples. Are there staples there, or are they missing, or are they flung up and out of range? So we have a few different discrete sensors that are actually used for belt monitoring as well. And the bulk scan can try to pick that up, because hey, I see the edge of the belt, edge of the belt. Whoa, what happened to the edge of that belt? And so it can trigger that output and say, hey, something happened. Now you got to go find it. But at least you'll know that there's something wacky with the edge of the belt, and that information can come off the bulk scan.
All right. Thanks, Dan.
All right. Eric, if there are more questions, if people want more information, what do they do?
Well, we've got your information right here on the slide. So, folks, you can feel free to contact Dan, of course.
Okay. That sounds great. Yep. And then I will get back to you and get you the right information. All right. Well, thank you very much, everyone. Thank you for attending.